Proxima b, the nearest mystery beyond the Sun. When scientists confirmed the existence of Proxima b, orbiting the faint red star Proxima Centauri just 4.2 light-years away, the discovery sent a ripple through astronomy. For the first time, a potentially habitable world had been found in the star system next door, close enough that future generations might one day reach it. What makes Proxima b extraordinary is its position in the star's habitable zone, the delicate region where temperatures might allow liquid water to exist. It receives nearly the same amount of stellar energy that Earth gets from the Sun, raising one of science's oldest questions: could life exist there? But being close to a red dwarf star comes with challenges. Proxima Centauri is volatile. It often releases powerful flares and radiation storms. These outbursts can strip away a planet's atmosphere unless it has a strong magnetic field for protection, something we have yet to confirm for Proxima b. Without such a shield, water would quickly vanish, and any chance of life would fade. Still, models suggest a more nuanced picture. If Proxima b is tidally locked, one side forever facing its star while the other remains in perpetual darkness, there could exist a narrow, twilight region known as the Terminator Zone. Here, day and night meet in balance. Temperatures may stabilize enough to let liquid water flow, creating a potential refuge for life. In this dim band, the world might glow in crimson twilight. Moisture could condense on rocky plains, and strange, resilient organisms might cling to survival in an eternal dusk. It's a haunting yet beautiful vision, a world neither frozen nor scorched, but balanced on the edge between the two. To explore these possibilities, scientists turned to the James Webb Space Telescope, JWST. From its vantage point beyond Earth's atmosphere, JWST can analyze the faint starlight that filters through a planet's atmosphere during transit. By breaking this light into spectra, astronomers can search for chemical fingerprints, oxygen, methane, carbon dioxide, potential signs of biological processes. However, there's a complication. Proxima b doesn't transit its star from our viewpoint. That means JWST can't directly study its atmosphere in the usual way. Instead, astronomers must rely on reflected light, subtle stellar wobbles, and infrared patterns to infer what its surface and air might be like. These methods are challenging, but ongoing advances in technology, especially with the upcoming Extremely Large Telescope, ELT, in Chile, promise to bring us closer than ever to the truth. Meanwhile, the Breakthrough Listen project is listening for possible technosignatures, structured radio patterns or transmissions that could hint at an intelligent civilization. So far, no signals have been confirmed, but Proxima b's proximity makes it a prime target for continued observation. The question, though, goes beyond science. If life truly exists there, what would it look like? Would it bathe in red starlight, photosynthesizing with infrared energy instead of visible light? Would alien plants shimmer dark or metallic to capture every photon? Or might life dwell deep underground or beneath icy oceans, protected from stellar radiation, sustained by geothermal heat instead of sunlight? Here on Earth, extremophiles have rewritten our definition of habitability. Microbes thrive in boiling acid, frozen deserts, and radioactive waste, proof that life adapts wherever chemistry allows it. If Proxima b hosts underground water or volcanic activity, it could offer the same kind of safe havens for hardy organisms. The planet's discovery has also reignited dreams of interstellar travel. Because it lies within reach of our nearest stellar neighbor, it represents a tangible destination. Projects like Breakthrough Starshot envision sending laser-powered microprobes to Proxima Centauri at a fraction of light speed. If successful, these tiny explorers could reach the system within a few decades, sending back humanity's first direct images of another world orbiting another sun. Proxima b, the nearest promise. Of course, optimism must meet reality. Proxima b may sit comfortably within what we call the habitable zone, yet habitability is not guaranteed by distance alone. It's a fragile balance between atmosphere, magnetism, and time. Orbiting so close to its star, the planet is constantly bombarded by flares of radiation and streams of stellar wind that could strip the air away molecule by molecule. If it once had oceans, they might now lie hidden beneath frozen crusts, locked away in silence. And yet, there are reasons to hope. Proxima b is about 1.3 times the mass of Earth, suggesting it's a rocky world, perhaps with a molten metal core still churning deep below its surface. If that core generates a magnetic field, it could act as a natural shield, deflecting radiation and preserving what remains of its atmosphere. In that invisible protection might lie the difference between a barren wasteland and a world where chemistry still dances in the dark. Astronomers are now looking beyond Proxima itself, toward the wider Alpha Centauri system. Here, two sun-like stars orbit each other in a slow cosmic waltz, and new candidates for planets are beginning to emerge. If even one of them hosts oceans or a stable climate, it could mean that our stellar neighborhood is far more diverse than we ever imagined, not empty, but alive with potential. Each of these worlds could represent a different path nature has taken, a different experiment in the grand laboratory of the cosmos. The discovery of Proxima b has already shifted humanity's perspective. Before, the nearest stars were only pinpricks of light, unreachable, unknowable. Now we can imagine standing beneath a crimson sky, watching the faint glow of Proxima Centauri rise and fall, its light scattering across alien seas. We can imagine winds sweeping over metallic mountains or auroras dancing endlessly in a thin, charged atmosphere. Whether such visions are real or not, they remind us that even in the familiar darkness between stars, new stories are waiting to be told. And as our instruments grow sharper, from the James Webb Space Telescope to the upcoming Extremely Large Telescope, every photon of starlight becomes a clue. Each faint reflection, each spectral line whispering through the void, could contain the signature of clouds, oceans, or even life. These signals, fragile and ancient, remind us that the story of existence may not belong to Earth alone. It may be written across billions of skies, a cosmic manuscript still being revealed. So we keep listening. We keep reaching farther. Because every attempt to find another world teaches us something about our own, about how rare, and yet how possible, life can be. In the search for others, we confront the essence of what it means to be human. The need to understand, to connect, and to dream beyond the boundaries of what we know. Somewhere out there, perhaps under a dim red sun, waves may still lap against an alien shore. And if they do, they echo the same rhythm that beats within us, the pulse of curiosity, the will to endure, the spark that refuses to fade. Proxima b may remain distant for now, but its discovery lights a path forward, a quiet invitation from the universe itself. Keep exploring. Keep believing. Keep looking toward the stars. Because one day, when we finally cross the darkness between suns, we might realize that we were never truly alone at all.